This is a regular hexagon, which means that all the sides are the same length. I've been told that the vector O to A, like that, is vector A. And I've been told that the vector A to B is like that. So that allows me to describe other vectors in terms of those. For example, if I want to talk about any other vector in this direction, I know it's going to be some multiple of B, because B is in that direction. If it's the same length as this line here, then it will be identical. It will be the vector B. Similarly, if ever I'm talking about a vector in this direction, I will say that that's a multiple of the vector A. If it is equal in length to vector A and in that direction, then I can describe it as just being vector A. So that is those two vectors were defined in terms of those original positions, the O to A and the A to B. But we can use those to now write down other vectors in terms of A and B. So for example, the vector from A to O, like that. I can see that is equal in length to vector A, but it is in the opposite direction. So I can say that that is the vector minus A, because it's in the opposite direction, hence why it's going to be a minus. So I can say that A to O is equal to minus A. Next, the vector E to D. Well, I know that that is in the same direction as vector B, and it's also the same length as vector B, same size. So same size, same direction, so I can just call that vector B. Next, the vector O to C. So that is from here to here. Now I know that that is going to be some multiple of the vector B because it's horizontal. And in actual fact, I know it's going to be 2B. Because this is a regular hexagon, I know that if I went from this point to the centre of the hexagon, that would be vector B. That's the same as me doing that. And then from here to here, that is also another vector B. So all the way across there from O to C is 2B. Next, from E to B, like that. Well, I know that that is the same as 2A. From here to here is A, and from here to here it is A. So that is vector 2A. Now, all of these we've seen so far have been in the same direction as A, or the same direction of B. But the next one, you see, we want to work out the vector EC, E to C, from here to here. Now that is neither in the direction of A or B, but I can write that down as a combination of A and B together, because I know that the vector from E to D, that's the same as vector B, and I know from D to C, that's the vector A. So I can actually combine those two things together and say that the vector E to C is the same thing as B plus A. Or A plus B, if you prefer. And finally, for this example, we want the vector from B, the vector from B to C. So B to C is like this, in that direction there. Again, I can't do that directly, but what I could do is I know that from B to the centre of this circle here, I know that's minus A. And then I know from here to here that is vector B. So I can rewrite this vector then as being minus a plus b, or b minus a if you prefer, they're the same thing. So we've seen in this example how we can combine different vectors together to allow us to write new vectors in terms of base vectors.